All right, let's get started. Good morning. So, are there any questions about what we covered so far? So I'm going to kind of go through. I suddenly realized that the classes are over in a week, right? So I'm going to try to rush through the protection, actually through the security even more faster. Because there's a separate course dealing with security, right? And if you look at it, security is 90% because of other stuff like networking and all the other issues than the core operating system issue. We'll only cover the issues that the operating system can support or can show, right? And what I want to take away from that is that from the operating system perspective, if I mess up in terms of security, right, the amount of loss you can incur is a lot less than what you can get in an actual machine, right? And we'll see what that is in the next in a few slides, right? So don't blame us, it's the network, right? So that's what I want to cover at this point, right? So we left off with this notion of access matrix, and before we dispersed last time, I was telling you, like, the matrix can be pretty large even without what we're talking about today, right? Because it basically gives the entire policy for the system, right? It says for every user or every domain you can think of in the system, and for every file you have, this lets you define what each of the domain can do for the particular file, right? So this tends to be a massive matrix, most of which would be sparse, right? But we also need other stuff to make this work, because if you just have the mechanisms to just access privileges, you have to define who will create these privileges, right? So you need to have a notion of somebody who's sort of the owner. So you don't want this magical person to have complete power over the system. You want to be able to specify here what privileges you have, meta privileges you have in terms of manipulating this table, right? And you have to remember, from an OS perspective, we don't care what you do. We don't care what the policies you say. We don't care if D3 has to be reading F2 or should be having write. That's up to you as a user, right? All it has to make sure is whatever guarantee it gives you regarding who should write into this, who can switch, whatever. The implementation is entirely up to the operating system, right? So if the operating system let D3 read F1, that's a violation. We want to prevent that, right? If operating system let D2 write something here when they don't have certain privileges, that's a bad thing, because they shouldn't have more privileges, right? So that's the one thing it wants. That's our responsibility. What you write in there is entirely up to the user, and you can shoot yourself. And that's one of the security violations you'll see when you talk about security, right? For example, if I give write access to all my files to the world, right? That means anybody can modify my files, right? Which means that so I can put my grades, you can come in and change the grades for all you want, right? And from our perspective, that's not a violation, right? If I gave write privileges to every file to everybody as owner, right? Then the OS is doing the right thing. You gave privileges, everybody should use it. That's a security violation, but not from our perspective, right? Does that make sense? So some of the meta things you want to do is the ability to switch domains, right? Which is sort of what sudo does. So essentially, now you add the domain itself as part of the access matrix. So we had this original stuff before. Now you add this stuff, right? So which means that D4 can not only read write F1, not only read write F3, but can also switch to D1, right? So from D4, they can switch to D1 through some mechanism, for example, like sudo, right? So they can sudo from D4 to D1, right? So if you follow along, so once you're in D1, you have all the privileges of D1, right? Which means that you no longer can modify this file, right? File F1 used to have read-write privileges for you, but once you switched, you're now in domain D1, where you can only read the file, not modify the file, right? And once you go from D4 to D1, you can switch to D2, right? But you can't switch to D4 directly, right? So once you do the switch, now you're in this new domain where you lose some privileges. You no longer can write these files, and you're only allowed to switch to D2, and D2 lets you print, right? So you have to follow along these things to figure out what privileges you have. So you're kind of moving across domains. So in each domain you have certain privileges, and at some point you may not be able to switch anywhere. So you kind of stuck, right? And figuring out if there's loops here, figuring out if you're in the wrong area, figuring out if you move into a place where you need to write something, right? So for example, if you switch to D1 and you need to write something at that point, you need to modify F1. With this mechanism, you just can't, because when you switched over, you lost the privileges. So that's up to the user. Somehow you do the right thing. But this is the way to kind of let you switch and specify what the policies were for switch are, right? This is a very nice way of expressing the whole thing. It's going to be extremely big. It's going to be extremely humongous to deal with. But if you can deal with that, this tells you all the policies that are possible in a file, for a particular file, right? The challenge in real systems is to not only manage this big array, right? So we kind of separate that by capability list and access control list we talked about, right? Basically storing it on the row basis or column basis, but also figuring out how to manage these things, right? How many of you used access control list in AFS? A few of you, right? So access control list goes beyond the Unix read, the group, owner, and world setting, right? So you can actually give specific rights to specific people. So you can say, my friend can have write access, this friend can have read access, this person can have whatever access. And Windows XP does that, Mac does that, and so on, right? So you can specify those on a particular file, right? And you can also have groups, right? And AFS lets you have more complex groups. It does not go far enough, right? For example, AFS, it's a global file system. I think I mentioned it at some point, right? So if you go to /AFS, you can see all the file systems available. So if you go to /AFS/Stanford.edu/something, you can look at files that people in Stanford are give out, right? And they cannot really give you write privileges and all the other access because of the way AFS was constructed. But in a truly global file system, you ought to be able to specify all those, right? So if you're in a truly global system, this domain will encompass the whole world, right? So you'll have to give privileges for everybody at Notre Dame, everybody at Stanford, everybody at Berkeley, everybody everywhere. So you can say people from Stanford can, that person from Stanford can modify my file, and so on and so forth, right? So regardless of how you cut and dice it, this is big, massive information. It's all there, but you have to sort of manage it, and that's sort of one of the things that you kind of worry about, right? So for example, if you cut it along the access control list, where for every file you have all these entries, right? If you have access list of, let's say, 5, right? Then you can sort of, as a human being, kind of recognize who they are. If you say, okay, I gave access to Bob, Alice, and Tom, and hopefully you know who they are, it kind of works, right? But if this entry gets to be really large, right? So suppose you gave access to the operating system class of Spring 08 at Notre Dame and operating system class of Spring 09 at Stanford, and so on and so forth, then you have to kind of figure out who you gave access to, who you took access from, right? And that becomes a hard thing to manage. And there are no good solutions at this point. I mean, that's up to you. And if you give privileges, then you are done, right? The capability list model is supposedly good because it basically tells you what each domain can do, right? So that tells you in one list, you can look at the list and say, okay, these are privileges that I have, right? So it tells you what privileges are. In the access control model, you don't know what privileges you have, right? So you can ask a particular file and say, for this file, do you have access? Easy to know. But you can't go into AFS and say, list me all the files that I have read access to, right? Which would mean that you have to go through for every file and figure out what you are. Because the access control list basically is per object, so you have to look at each object to see if you have privileges, which may or may not be a good thing, right? It's not a good thing. So how many of you use the quota command? There's a command in all the Unix systems called quota. It tells you how much disk quota you have. AFS gives you a quota and you're supposed to manage it, right? So, and disk quotas are typically per file system, right? It basically goes by all the files that are owned by you contribute to your disk quota, right? So what do you think should happen when you do a Dropbox, when you drop off some files? should the quota be counted to you or counted to me? Right? You dropped off some file as you, right? Should the quota count as towards me or towards you? You can see the benefits of either policy, right? So let's say it should count towards you, right? Which means that now this file counts towards you, right? Which means that if you create a 512 megabyte file and put it in my Dropbox, and you're just being malicious, so you created like 10 copies of the stuff and put it in the Dropbox, right? Which means everything's being allocated to you, right? Then if you try to figure out why is my quota suddenly gone, right? You have to go through all the files in AFS to figure out which files you owned. Some of you may have tried this, right? So if you kind of write these files and leave them around, you have to look at all the files to see where your quota went, right? If it's the other way, if it should be counted towards me, I have to go around doing this. I have to go around looking at all the classes to see what people are submitted to see how they're using my quota, right? So either way, I need to know all the things I have so I can protect myself. Capability lists are good for that because it tells me exactly what files I have, what I have. But this is a big mess, but that's the nature of the protection stuff, right? There are other privileges, right? There are other privileges in this notation. They call it with a star. So that means you get to copy those rights. You get to copy those rights to other users. So in this case, D1 can have the right privileges and copy it to another user. So for example, D2 has read star. So D2 can copy these privileges to somebody else. It can give the privileges to somebody else. So D2 could have given the privileges to D3 because it had the special privileges where whatever privilege it had, it can give it to somebody else, right? So initially, D3 did not have the read access, and D2 gave the read access to here. So it copied whatever it had into this stuff, right? So that's one privilege where I can do escalation. I can give my privileges off to somebody else, right? And of course, there's the owner privilege, which trumps everything. Owner can do whatever. So in this case, D2 can do whatever. So D2 can give write privileges to D3, even though there was no explicit right there, right? So owner means star for every privilege you have. So D2 can decide to give write privileges to D3. It can decide to give write privileges to itself. It can take away all the privileges and put them back as long as it's an owner, right? And you would have realized that when you're using the system, sometimes you would have gone and removed all the privileges from you, but you can get it back because you're the owner. So as an owner, you have all privileges. Yeah?
Is it possible to make yourself not an owner?
No, there has to be some owner. So you have to make somebody else an owner, right? So if somebody if you can give the file away to somebody, then you can lose your owner privileges, right? And that's usually protected. You can't just do that, and you can kind of guess why, right? Why would I not be allowed to relinquish my ownership and give it to somebody else? The answer was the one I was just talking about regarding quotas, right? If I can relinquish my ownership, right? If I want to be malicious, all I have to do is create a 1 gig file and make you the owner. And now you're out of this quota, right? So I can't be allowed to just give up my ownership, right? So if it is if I'm doing something good, then I should be allowed to do that, right? So if I'm actually giving you a file that you care about, you want, and you want it from me, then ownership, me giving ownership to you, that's one thing. Otherwise, I can just go around changing, like writing 10 gig files and all your stuff, or writing a quota, so none of you can do anything, right? I'll keep doing the stuff, right? So that's one of the things you need to worry about. So you have to protect those things, right? So essentially now it becomes more complicated because now you have switch privileges, you have control privileges, which is sort of like a owner privileges and all those things. So you can think of, as you think of more complicated ways to build these things, you can think of adding all the stuff, and that adds more complexity. That makes this list bigger and bigger, right? Now you kind of appreciate why I sort of alluded to the fact that Multics had multiple like onion layers kind of domains. And it had notion of different domains with different privileges and so on and so forth, right? It is really powerful. It lets you give fine-grained privileges. I can say you only have this privileges and not certain privileges kind of thing, right? But it's a nightmare to manage, right? So Unix only defines two models, super user, everybody else, right? Everybody else is equal. So you and I are exactly equal on the system as long as we don't become super user, right? I have no more privileges over your file than I do, right? So there is no hierarchy among us. When you become super user, then you have no different privileges than anybody else, right? So any of you can mess up that machine for all you want, because when you do a sudo, you become super user and you have complete control over the system, right? I can't say you have complete control over, say, installing your own kernel and nothing more, right? I can't say you have complete control over installing kernels, but you're not allowed to kill a process owned by your friends. You can't, right? So it's a limitation, but the other alternative is you have all this complexity with managing all these things. So somebody has to keep track of all this stuff, which is what Multics did, and that is not practical. So we kind of went to the Unix model. We sort of creeping up with access control lists and stuff to make it a little bit more powerful. But the full model that we saw in the previous slide, it's pretty nice, but pretty unwieldy to operate with. Especially if you're working on AFS kind of space, where you have like about 20,000 users and a couple of million files in the AFS space. Somebody has to keep track of all this humongous list to see which student has access to what file and so on and so forth. So you have to kind of relegate and kind of get away with it. So that's the one operation we haven't talked about is the notion of a revocation, right? Getting privileges back from what I gave you, right? So for example, if I trusted you on the lab and I want to untrust you now, right? I need to go and get your privileges back, right? So if I had the whole access control matrix, I can kind of go around the matrix and figure out what privileges you had and remove those privileges from you, right? But since we don't, with the access list model, right? If you have access control list, I have to look at each file and see. So if I want to globally remove something from you, I have to look at all the files and remove privileges, right? Otherwise, I can kind of look at a file and remove the privileges from you, right? So for example, if I had a file called grades, I don't want to give you access anymore. I look at the file and say, you will no longer have access to this stuff, right? Whereas if you want to do with the capability list, I have to look at all the users in the system, go ask each of them, do you have privileges to this particular stuff? So somehow you have to figure out what privileges that each one of the users have and then take the privileges, right? So both of them are good for something and bad for something, right? If I want to figure out everyone who has privileges to a certain file, access control list is good because access control list maintains all the users who have access to a certain file. If I want to figure out all the files that you have access to in a given file system, capability list is good because it tells you all the files that you have access to, right? If you want to do the other way, then both these approaches are kind of bad, right? So to revoke privileges in access control list, if I know exact file, I can just go and take your privileges. You guys would have done that, right? If you do a chmod in Unix, you can remove the privileges. In Windows, you go to the GUI and figure out what the privileges are, right? You guys must have done this, right? So for example, can you see from the back? I don't know how to make this font bigger for this stuff, right? So essentially, if you have Windows or something, go to a file, right-click on it, and what does it say? Properties, right? It'll give you this stuff, which tells you all the properties of a particular file. So if you look at the security, it tells you all the users and what privileges they have, right? And that's the access control list for the particular file. So this file, what percy.sys or something, right? So these are the different privileges. So this is administrator for this machine. If you look at here, it tells you what the operations are, what is allowed, what is denied, right? In this case, administrator has full access privileges, right? So they can full control, which basically says they can do whatever they want. But they can modify read, write, special permissions. Or what. They can't do special permissions, but essentially they can do all the stuff, right? And there are different users which have different privileges. Users, which is probably what I am, I have read and execute privilege and read privilege. I don't have any other privilege. I don't have write privilege. I don't have special permissions. I can't take full control, right? And it's kind of grayed out because I can't modify any of those. I don't have privileges to modify this. I can't modify. So I look at this, right? So I can look at these. So I can create this for any file I want. Let's see what happens for the. So for the lecture PowerPoint slide, right? I happen to be one of the owners. So I have. I'm not sure why I don't have access allow privileges, but I have deny privileges, right? So I can deny full control to myself, which I don't want to do. But what I want to do, I can add users, right? I don't know of any other user name, but I can add different users. So I have control over giving privileges to different users, right? So I can give privileges to different users and so on. Because I'm the owner, so I have these privileges. So this is their access control list. It defines all these operations and the set of users, right? And hopefully the set of users is sort of small, right? Administrators could have many OIT administrators, but hopefully it's not large, right? Because if it is large, then it's kind of hard for me to manage. If I have to give a privilege for each one of you, I have to create 52 entries and make sure that they're all consistent, and that gets to be kind of painful after a little bit, right? That makes sense, right? So there are other attempts at enforcing these capabilities and other mechanisms, not just from an operating system perspective, but also from a language perspective, right? So you can have the language define what privileges you have, what operations you can do, and depending on how the language is written, how much you can get out of the sandbox that it creates for you, you will get good privileges, right? So one of the languages that you've used in that sense is Java, right? Java's claim to fame is that it can run on any machine basically using the JVM, but more importantly, it runs inside a sandbox, right? So you've heard of the Java sandbox, right? Do you know exactly what it means? So it means that Java controls what you have access to, right? So depending on how you run your Java program, by default you get certain privileges, right? So for example, if you run as an applet, that means you're downloading the code from somewhere else to run that particular program from a different site in my browser, in my machine. The set of privileges which are given to you include I can create a connection back to the site where I came from, right? And that's it. I think I cannot access any local files, right? It's a sandbox because I can call back where I came from, but I'm not allowed to open any files locally, right? So that's one set of privileges. It basically says I cannot allow any local files. If I run it as a local Java application, then it can have access to the local files because it's a program that you are running, so it has privileges to local file. But those are not the two things that it can do. It can actually do anything you want. In fact, you can set up a capability manager which can define precisely what you want. So for example, you can say, you can run this program. It will only let you connect to nd.edu or the dormitory network, which are different IP addresses, or let's say Yahoo and Google, nothing else, right? So you can implement a capability manager which your Java program will ask before it can give you privileges. How many of you have written a code using capability managers in Java? So capability manager is a very powerful concept. The challenge is it cannot be called by you, right? If you cannot implement a capability manager which runs your program, because then you can violate it very easily, right? So what happens is your capability manager is set for you before your call. So if you're a process, if you think of it as a process abstraction, before you call a process, I should set up a capability mechanism and then let the process run, right? And the process can only get whatever was given to it by its parents. It can't modify whatever. So it can't become a creator. It can't change whatever. It can give up something, but it can't add something. And that's the model you want. So the way you do that in Java is through stack, right? So if you want to create a new Java instantiation, you can create a capability manager, attach it to the instantiation, and call your program, right? And he'll do a stack inspection, meaning he'll go through the stack, he'll see who called it, and so on and so forth, and see if any of them will give it privileges, right? Typically, when you call a URL, you call a URL loader, which gives you that capability that we talked about for free, but you can actually implement anything you want, right? Many of you haven't done that, but it's a very powerful tool, it's a very easy tool to do, and essentially that's the language. So it guarantees that when you're inside a thing, you cannot modify your stack. You cannot modify your privileges that are given to you, because in Java you don't have access to a pointer, so you can't manipulate these things. All the privileges are there for you, so you cannot keep looking back to see if anybody will give you privileges, and that's one way to do that. And there's been other attempts at doing this sort of a thing, right? And JVM is one of the stuff. So here's what happens, right? So if you for the different loaders, right, you have to set the capabilities of what the sockets can do. So even though it looks like a socket code which opens some network connection, depending on what privileges were given to you before you started, right? So if you were started as a URL loader, and if it's an applet, you can say which domains you are allowed to call, right, and which ones you cannot call, right? So all you open and all the connection calls essentially look at the capabilities of what you were given before you started, and if it's not there, you'll fail, right? So if you're there to write Java code for a living, and you're running it as application, you would have to deal with capability managers, because that tells you what kind of a how much you have access to the system. It lets you control the stuff, right? So that's one easy way to deal with that, because it's a capability per application, and you as an application developer ought to know what is allowed, so you should be able to build the stuff, right? That's the assumption, and apparently that's not really true, because I've seen very few people who actually modified capability managers, right? And for some reason we don't teach them in the programming classes too, but that's one of the things that defines why applet behaves a certain way, application behaves a certain way, because of the privileges that you inherit, right? So that's the notion of a protection. So the goal here is to only give access to different people. The goal here is to have you figure out what you want to give, but the operating system defines this notion of access control list or what have you to enforce those, right? And frequently you run into issues where it's not the OS's fault, it's the application's fault, right? If you follow the bug reports about different operating systems, you will find that there'll be some bug where somebody gave write privileges to some file that they shouldn't have, right? So if Microsoft gave write privileges to etc. password file, so anybody can write their own entry, right? Whose fault is it, right? Is it the operating system's fault, or is it the user's fault, right? It's kind of messy. Microsoft is the one which does that, because they are the user and the operating system developer, right? But many times you'll see that this sort of a thing happens, right? You guys may know of cases where some faculty let some files read where you shouldn't have read privileges, or write where I shouldn't have, right? I'm sure none of you are going to tell me if you knew that, right? But you at least heard of those things, right? Where somebody gave privileges where they shouldn't have, right? Right? So OIT kind of protects you from yourself by basically saying private. If you put something in the private directory, they have a little script which goes and makes sure that the private directory is not readable by anybody else except you and OIT, right? They do that because they just want to be nice to you, or they think that you need to be helped or something, right? And they make the public readable kind of stuff, right? But you can create something on your home directory, and people can read all the contents and stuff. You might have heard, or you must have heard of privileges and stuff. And that's essentially, from an OS perspective, that's not our fault. I mean, we give you ways to protect your data. You opened it, so hey, it's your problem, right? But I'm sure most people don't take that tone, right? Especially if it's some important data, I get into trouble. I would rather magically something happens that it doesn't go that way, right? So that's sort of, I'm kind of saying in a tongue-in-cheek fashion, but the notion of security comes in where we don't exactly care where the fault is, but you want to define certain notions of protecting your content, protecting stuff, and making sure things work, and so on and so forth, right? Even though we can say it's not our fault, it's somebody else's fault, we are all in it together to solve the problem of how to make sure that the users have some confidence in what they're storing, and so on and so forth, right? So that's the notion of security. And security, I can't possibly go through this in 20 minutes, because you can't possibly go through this in one undergrad class. I mean, security, people work on it on very large number of topics, right? There are issues of protection using encryption and all the mechanisms and all the math behind it, cryptography and social engineering and so on and so forth, right? We have a couple of classes which deal with security, but the whole issue is much bigger than that, especially after 9/11 and all those things. People are really worried about security and the whole gamut of issues, right? So I'm just going to talk about very high level a little bit and just to give you a flavor, right? So in security, you have the notion of a threat and attack, right? And you also have to have a notion of trusted computing base, right? The trusted computing base is the most important aspect, which is usually kind of forgotten, right? The threat. So this notion of security is no different than what you would do in real life, right? So for example, if you're walking through the airport, right, you need to have a clear understanding of what the threat is, right? And you need to have a clear understanding of how the attack will come, and so you can protect against those, right? So for example, if you're building the security system for Southern Airport, right, you don't protect against aliens walking through the metal detector, because the chance of that happening is very minimal, right? So when you develop these systems, you don't build a system which protects against any living or non-living thing which can move through the stuff. You kind of assume there are usually human beings and they have like certain stuff. I mean, it sounds kind of obvious, but it's not so obvious when you go beyond certain things, right? So in this case, it looks obvious, but for example, when you build a house, right, you don't build a house, your front door. So what do you decide? How do you decide how strong your front door has to be when you build a house, right? Or when you're in a dorm or something, right? Do you build a Fort Knox door, or do you build like a normal door, what have you, right? I mean, how do you decide that, right? You decide that by having a notion of what the threat is and what you're protecting against, right? So when you build houses in South Bend, you assume certain kinds of people who are attacking you. You don't assume like Mad Max style, people jumping over the roof and kind of stuff. So you don't protect, right? So it's kind of weird because when we built a house, one of the things we figured is all the houses here have security alarms on the first floor, right? And by convention, none of them have security alarms on the second floor, right? So most of the houses, you can actually take a ladder, go to the second floor, and you can get into the house, right? But that's considered acceptable. So if you go around, you see all this ADT symbols and everything, right? And that's so for people who come up from, my wife comes from New York City, so for her that sounded really awful because putting a ladder and going up to the second floor seemed like a thing. But essentially you do this kind of stuff all the time. So you're not building a security system, right? If you don't understand this stuff, you would think that building a security system is about building a bulletproof kind of system, and then you have problems when public perception, all those things. The other thing is the notion of a trusted computing base, right? You have to define what you can trust, and you have to fully trust it to build the security for the system, right? If this is violated, the whole thing will fall apart, and it should fall apart because you can't build it against your trusted computing base, right? For example, if you are a security system, you have to assume, like for example, you have to assume that cops can be trusted, right? You can put some kind of a thing to make sure that they are cops. So if you're a cop, you probably have ID that you have to show to get in kind of stuff. But if you assume that once you moved along into here, I can trust. If I initially found out that you're a cop and I can trust you, then I have to trust you. I cannot say, I cannot question this decision, right? So a lot of thought has to go into to figure out what is a trusted computing base and what is not trusted. I'm protecting against the threat, but I'm not protecting against the trusted computing base, right? For example, in a computer, right? When you run Windows XP, you implicitly assume that the firmware hasn't been hacked to change something that Windows XP learns, right? You have to assume that the firmware is telling the Windows XP that you have 2 hard disks and this is where you have to write, right? If you modified the firmware to tell Windows XP that the Linux partition is really where the data partition is, so it can format it, right? That's because you have to trust the firmware. So in your laptops, your operating system has no control over whether trusting your firmware. The firmware is trusted because that's part of the trusted computing base, right? You might have heard of Microsoft trying to fix that by making the firmware using a trusted computing. They had different terms for it, essentially to make sure that you can trust something. But the important thing to remember is you cannot protect against those stuff, right? So you'll always hear folklore about how you can do this with the firmware and all those things. As a security, you have to say, well, that's fine, but that's part of a trusted computing base. We can't fix that, right? The challenge that I want you to think about in this class is, does the operating system become part of the trusted computing base or not, right? And that's the argument that people would have, right? Should I be able to trust my operating system so that I can build stuff on top of it, right? So if I build some kind of privilege scheme to say, I want you to have write privileges, I want you to have read privileges, but if the operating system itself is compromised and compromised or malicious, it gives Microsoft also access to the files, right? Should that be considered? How do you deal with that, right? And that's never resolved because obviously nobody wants to take responsibility for that. For the most part, we assume that operating systems are part of the trusted computing base. You would like to trust them, right? And that's where it stands, right? So if you don't understand anything else from this class, you need to understand that security is not about making things secure. It's about you understanding the risk and understanding what exactly is being protected, understanding what your pieces that you can trust, right? And as long as you have the trusted computing base and you have reasons to believe that these are trustable, right? So sometimes you have no control over those. So essentially, if you trust those, and you kind of move along, right? So one other example in real life that comes in is when you show your ID at the airports, right, for security. They trust it because if it looks like it's been printed by some state agency, they trust whatever it says is true, right? It's nearly impossible for them to not trust the ID that you show, because then the whole system will kind of fail. They have to kind of trust something. So they say, okay, if you have a state issued ID, and if it looks like you're the person on the face on the card, then you're okay, right? They rarely go into to validate the card and then validate the agency which did that and all those things, unless of course you're flying different scenarios. So if it is good for you, I can bet you're not going to walk into NSA with those kind of credentials. And again, different risks, different attack models, and different things you do, right? And there's a whole bunch of issues we'll talk about in security, which I'm not going to, I don't have time to go through. Some of the issues that you worry about is breach of confidentiality, right? Which is a big security issue, right? Figuring out, so if I don't want you to find out who I am, and if you find out, it's a bad thing, right? So if you think of spy novels and stuff, I don't want you to see who's logged into a machine, right? In operating system, we don't really care. So if you see who's logged in, it tells you kind of thing. But if you want to make it secure, it has to be controlled. It has to only give you the privilege of finding out who's logged in based on who you are. For most systems like Linux and Unix and all, we don't care because we don't. It's just too complicated. But those are security privileges you have to worry about. You have to worry about breach of integrity. So if I save something, I want to have guarantees that what I saved is what I get, right? In the real operating systems right now, we try our best to give you what you have, but failures are okay because we just are not operating in this kind of a serious model. You have to make sure breach of availability is an important security concern, right? Breach of availability means that if some certain file is not available at the time you wanted, right? It's a security concern because that file may have information about all the users, right? So if I have a list of all the students in this class, If the file is not available, from an OS perspective, a certain file is not available, so you're kind of unhappy kind of thing. But from security perspective, that means I can't make a decision of whether I should let you in or not, because I need to know who's coming in. Something is not available, that means my security either has to fail or I cannot let you in. So these are different services that, there's a whole bunch of things you can look at the security thing. So they worry about all this stuff because from a security perspective, these are important. I'm saying it's okay for us not to worry too much about it because these are set of constraints that you will learn in the security class. But from an operating system perspective, we don't particularly worry about this. We want to figure out what mechanisms we can give you to implement these things, right? So, availability is not as bad to us as it is to a security person, because availability to us is, we sort of do our best to give you availability, but there's no life or death based on that, right? And there's a whole bunch of ways that you can trick the operating system to give you more privileges, right? And there's stack overflows and trapdoors and Trojan horses and stuff, which essentially, sort of in a nutshell, I trick you to run something on my behalf, right? There are different ways to do this, and I'll show you some ways to essentially do that. All of them, what they try to do is make you run a code on my behalf, right? So simple way, when it's a Trojan horse, is I give you homework po4.c, right? I leave a little piece of code in there, right, which is malicious, right? So I give this code to you, and you compile it, and you run this program. So when you're running it as you, right? So now I got this Trojan horse program running as you, and violating your privileges, your confidentiality, and all those things, because he can reveal everything about you, right? And that's essentially what you do in the trapdoor and all those things, and stack overflow and everything, sort of in different ways of doing the stuff, but essentially that's what they're trying to do, right? Basically making you run something for me by giving you, so as when you're running something, I kind of give you a Trojan horse, something that will run as you, right? What's the security implications of that from an operating system perspective? How much damage can I do by doing that? How much privilege can I do? How much? So if you look at the domain, the access control matrix, right? If you are D1, I'm D3, right? I gave my source code, right, that I gave to you. You somehow ran my code as D1, right? So I virtually did a switch from D3 to D1 because I'm giving you this program. You're running it as me. So now this program is running as you, right? How much damage do you think it can do? Can it destroy the system? Can it read? So if you're D1, I'm D3. Can it read something that is part of domain D2? Right? The answer is no, it can't, right? Unless the access control matrix allowed D1 to switch to D2, right? You running all this stuff will only means that I'm switching from me to you, right? Unless you are root, in which case I get all the privileges, right? So when you see lots of the buffer overflow and all those things as a serious problem, and you see all the press about all the stuff, right? You have to understand that some of the stuff which can happen is not as bad as what the popular press will make it sound. Some of the stuff can be potentially bad, right? So if I give you this homework project 4.4 and you ran it, all I have your privileges, right? In which case I can look at your files, right? Remember, we're all equal in Unix, right? Except that there's users and me, right? So I have access to all my files. You have access to all your files, right? So if I become you, I can delete all your files, right? For the most part, it's big deal because I can't destroy anybody else, right? So if you're not careful enough and you ran my code, then I can destroy you. In the worst case, I can delete all your files. I can't do any more harm to anybody else. You'll be unhappy, but sort of you're the one who ran the program, right? So you have to pay the penalty kind of stuff, right? To elevate, to go beyond that, to destroy the whole system, you have to become administrator, right? And that is still protected, right? The way to breach that is to give this Trojan horse or stack overflow or something to the super user, right? So when you become sudo and if you run my program, then I got you, because then since you are now elevated yourself to administrator. Now I got you. So the security concern that we talk about is not buffer overflow by itself only makes me run, give me privileges to you. But if you are not smart enough to run as yourself, but you're running as super user, then I get privilege to the whole system. So from our perspective, you have to understand what exactly happens with some of the things that people worry about. Popular press calls it, I hacked into the machine kind of thing. Like I run a virus and virus infects you. The virus only has as much privileges as who's running it. So if you're running the virus program, then it can potentially destroy all your programs. But it can't do anything else unless it can elevate and become super user, right? So as long as the operating system is working fine, the amount of damage is what it should be, right? It's not as bad as what you would see in some other stuff. So we'll talk about buffer overflow because buffer overflow uses some of the stuff that the operating system kind of does, right? The operating system and compilers kind of do, right? One of the things we do is when you, so if you wrote some program like this, right, and you don't check for how big the thing is, so essentially you're copying whatever is coming in the argument into this buffer, right? And if the buffer happens to be small, right, then you'll overflow, right? You'll keep writing beyond that, right? Because C does not do any bounce check. So if you in this case the buffer size was something, let's say buffer size is 100. If I copied 1,000 bytes, then it'll overflow and it'll keep writing beyond that, right? So most of the time you get a segmentation fault. I get some weird bugs afterwards. But if I'm malicious, I can craft this thing I'm overloading in such a fashion that I can use the way that the program is running to change your program to run something that I want you to run, right? So if I knew that this is how the stack is set up, right, where the automatic parameters and all those things are certain places, right, I override the buffer in such a fashion that I replace the return address to something else that I want, right, and I also put some code in there which will run something. So essentially, I make your program sort of suddenly morph into something like this because when it returns back, it looks like you have code in there for exec or something, and at this point, I have complete privileges to your system, right? But remember, when I say complete privileges, you have complete privileges as me, not as anybody else, right? So if I do this stuff right, so it's a painstaking process. It's not portable code, so I have to say, if you're using a core 2 duo on Linux, blah, 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 so I know exactly how the memory is organized, right? I know where the memory segments and all those things are. So I'm going to send this particular packet, which when it overflows, I know what the exact bug is, and it'll cause this stuff, right? And the OS can do some things to prevent this. It can make sure that it only runs code which it does not have write privileges or something, right? So there are some things you can do, but these are very common because they kind of use the way that the operating systems are doing. And it's not portable, but given the fact that there are only few operating systems out there, there's Linux and Mac and Windows and so on, right? So if I can figure out how to do this for Windows XP, version 1, 3, 4, 5, 6 or something, right? Then it can potentially be bad because I can, if I can somehow insert that, then I get privileges on all the machines. And given the fact that there are enough Windows machines, right? So this is a potentially bad attack, which has a lot of security implications. But this by itself only gives you privileges as me, nothing more. The attacker has to use that and run something else, right? Usually they download something and then use your privileges to try to break something else in your system. But that's the stuff, yeah.
Especially if it's a third-party program, how would you know where to find an unbounded buffer?
Sorry.
Like, how would you know where to find like an unbounded buffer so that you could do one of these buffer overflows?
Who's me?
It's not your own program. Like you don't see the source code.
The hacker, you mean?
Yes.
So that's one of the arguments against open source, right? So if you're open source, I know I have the source codes, I can look at this, right? Regardless, right? I mean, you have to assume that these people have practically infinite amount of time, right? So even if you knew where the buffer overflow is, you have to trick it with this kind of stuff, right? So it's not a trivial task. It's painstaking, right? I mean, it's not for the weak, right? I mean, you have to probably spend hours and days and kind of stuff, right? But think about it this way. It's not that much harder than people who hack the iPhone to put a different bootloader, right? They're exactly trying to figure out where these things are, where the bytes are, and so if you follow along on what people do for the iPhone and stuff, right? They exactly know how it's done. They exactly do the right buffer overflow, right? Something and all those things. So you need to exactly understand what these things are, right? It's a very painstaking process. So I'm guessing that if you have infinite amount of time, eventually you find out one of these things and then you do this thing, right? Why they do that, what's the amount in all those things, you should take a security class to figure out what that is. It's not for like people who are kind of bored and say, okay, let's do this for the afternoon kind of thing, right? So essentially, this is one of the things. So you kind of modify the thing. So your program now looks different, and then when return happens, it's gone. So I'm gonna skip through the rest of the stuff. So the last this one point. Let me finish with that, right? So there are certifications that you can get for the operating system, right? The Defense Department gives those things. So depending on what the certification levels are, if you want to claim that, your system has to be certain guarantee, right? The highest level is A, right? Which means that your operating system is provably certifiable, right? Very few operating systems are provably certifiable, right? If it's provably certifiable, be secure, it's nearly impossible to use, right? See, it's the same thing as a key, right? If you have the key which can be easily copied and all those things, it's not secure, right? So if the more secure you make your room key, right? If it is ultimately secure, you can say it will only open with this one key, right? But if you ever lose this key, you have to break down the house, right? Which is what you want for A, because if you're doing some real serious security stuff, right? For normal human beings, that's not a good thing. So you kind of operate in the I think Windows is like sort of in the C-ish, D-ish kind of level, right? The reason why things are not secure is security is very hard. How many of you use a password which is like 100 bytes long, right? How many of you use the same password over and over again, even though OIT tells you to change, you just kind of flip it, make sure it kind of gets through, right? I do that, right? But that's the challenge, right? Well, because there's a social aspect of it, right? Because I don't want to remember a 1,000-byte random string because I'm not a computer, right? So you try to figure out something that you remember, which just makes it less secure. And how you do that, a course in security will help you. So anyway, so that's all I have. I'm not giving you a sense of what security is, but just the sense of how big a topic it is. And you really should take a course in one of the courses in security that we offer. Right? I'll see you on Friday.